So here we'll take some of the examples. In the previous case, we have seen retrosynthesis of some of the compound. We have taken near about 7 to 8 examples. Out of that, they'll ask one example. So what we have learned? We have learned retrosynthesis of alcohol. Retrosynthesis of alcohol, number 1. Number 2, retrosynthesis of, that is the alkene. Then number 3, carbonyl compound aldehyde or ketone. Carbonyl compound aldehyde or ketone. Then we have seen retrosynthesis of, that is beta hydroxy or alpha beta unsaturated aldehyde, that is aldol condensation, or CH double bond CH, C double bond O H, alpha beta unsaturated aldehyde. Then we have seen retrosynthesis of ester, R C double bond O, O R dash, maybe same, maybe different. Then we have seen retrosynthesis of, that is cyanohydrin, R C O H. Here is a H and here is a Cl. Number 7, we have seen retrosynthesis of ester, R C double bond O, O R dash, maybe same, maybe different. Then retrosynthesis of malonic ester, there is a H, there is a C, you add R on malonic ester. So same thing we can write COOR, here is R or R dash. We have seen retrosynthesis of, that is the called as name reaction called as benzoin condensation reaction. Benzoin condensation reaction. Also you have seen retrosynthesis of alkyl halide, RX alkyl halide, and 10, the retrosynthesis of, that is the name reaction benzoin condensation reaction. So here you are having pH, then C, here is H, here is OH, here is a C double bond O, and also pH, right? So these are the 10 examples that they may ask in exam. Out of 10, they do not ask anything. So if you prepare this 10 example, of course, you get question of 2 plus 2 means 4 marks. 4 marks on this one and 1 mark on the, that is the short notes. So prepare short notes, definition, and one of the example. Preparation and one of the example. Here we'll take some of the examples. Number 1, if you want to ask any question, just you tell me the page number and the question number, so we can take that first. Okay. So for 2 marks, they'll give the target molecule that it has to prepare. So TM is, here is this one. TM is this one. So you should know first what is the type of TM, whether they are from 1 to 10 or not. So can anyone tell me what is the name of this TM 1 to 10? Yes, anyone? 1 to 10. What is the name of TM? Target molecule. Where is the alcohol, alkene, aldehydes or ketone, alpha beta unsaturated aldehyde, or anything other? It is the alpha beta unsaturated aldehyde. Okay. So here is alpha carbon and here is a beta carbon. So it is alpha beta unsaturated aldehyde. So it is a type 4. Right? It is a type of 4. So first you should know what is the type of this compound. And you know, alpha beta unsaturated carbon compound can be prepared by the aldol condensation reaction. It is the aldol condensation reaction. So you have to carry out, it's a disconnection. So in retrosynthesis, you have to write down first, that is the FGI. For this one, you have to write down the FGI. So if you are not carry out its disconnection, then you have to carry out its FGI. Writing one functional group for the another functional group is called as the FGI, functional group interconversion. So how can you prepare this one? So you can prepare from, that is the beta hydroxy carbonyl compound. Okay, so here is a double bond. So you can add water. There is a H already. Also there is a H already, and you add a water on here. So addition of water takes place like this one, H and O and H. So it is a FGI, functional group interconversion. Then you can carry out, it's a disconnection. Now in disconnection, you have to break molecule in a such a way that you can get corresponding possible fragments. So this sigma bond open on this carbon. So this carbon becomes CS2 and this carbon becomes positive. So this sigma bond will shift here and there is a removal of H positive. So here you are getting corresponding fragments C double bond O. Here is a CS2 negative and here is a CS2, CS2 and here is a C double bond O and here is a H, right? So these are negative charge, and for this negative charge we can either write Grignard reagent or you can also write corresponding CS3. So if you write CS3, then you can get corresponding synthetic equivalent like this one. Okay, C double bond O and here is a H, here is a CH2 and you can write corresponding synthetic equivalent. You write one H. It is called as a synthetic equivalent. Synthetic equivalent. So after writing this disconnection or retrosynthesis, you have to write down the net reaction. So let us see the net reaction for this one. Net reaction. Sometimes in your book they might have given only this one. You have to also write down its a corresponding net reaction. So in net reaction, here you have to start from the synthetic equivalent and you have to write down the net reaction. So here again same thing, C double bond O. Here is a CS2, 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 C double bond O and H. Here is a CH2 and here is a H, means CS3. The reaction takes place in the presence of base, alkali, NaOH or KOH or sodium ethoxide. It is a base. Base has ability to abstract a proton. So this sigma bond open on this carbon. C becomes negative, H becomes positive, and this H positive is abstracted by the base, and you can get corresponding carbanion. So there is a formation of carbanion. CS2, here is a negative, double bond O, and remaining part as it is, C double bond O, and here is a H. Further, this carbanion form, it attack on the carbonyl carbon. Oxygen is more electronegative as compared to carbon. Pi bond open on the oxygen. O becomes negative, C becomes positive. So this negative will attack on the C positive, and you can get corresponding such type of, that is the double bond O. This CS2 will attack on this carbonyl carbon. Here is a C, here is a O negative, here is a H, and this will attack here. You are getting corresponding alkoxide. Alkoxide further undergo protonation. There is formation of a beta hydroxy compound. So here is a C double bond O. Remaining part as it is, C O H. Here is the H. Here is a C H and Also I can write H like this one. So you are getting a beta hydroxy aldehydes or ketone. Okay. So beta hydroxy aldehydes or ketone, and when you heat at 80 degree centigrade temperature, then it undergo dehydration. There is a removal of water. How this sigma bond open on this OH, there is removal of OH, carbon becomes positive. So this sigma bond will shift here and there is a formation of double bond. So you can get corresponding alpha beta unsaturated aldehyde. So you can get such type of alpha beta unsaturated aldehyde, C double bond O, and here is a double bond. So this is your TM that you have to prepare, right? This is your TM that you have to prepare. So in this way, you have to write down corresponding disconnection. Okay. So under this category, you can write number of the examples. So just I will write only the examples that can be asked under this category. So it is alpha beta unsaturated carbon compound. Actually, it is cyclic compound. Even though you can take the open chain compound. If it is open chain compound, then you are having corresponding the two different compound. One is a carbanion and other is a carbonyl compound. So here I will take one more example of alpha beta unsaturated carbon compound in which it is an open chain compound. It is an open chain compound. So the next TM is, here is the pH, right? Number 2 example, here is the pH, here is the CH double bond, CH, C double bond O, and EH. It is a TM. It is also alpha beta unsaturated aldehyde. Alpha beta unsaturated aldehyde. So again, same thing. It is under the same category, and it is also under the same category. So of course, also you have to first carry out its FGI, functional group interconversion. In functional group interconversion, you have to add water in such a way that there is a formation of beta hydroxy aldehyde. So there is addition of water, pH, CH, here is the CH, C double bond O, and here is the EH. So you add water here. It is alpha carbon and it is a beta carbon. So you have to add water on the beta carbon atom, and here is the EH on the alpha carbon atom. Then further it undergo disconnection, and in disconnection you have to break this molecule in such a way that you should get corresponding possible fragments. So how can you get it? So this sigma bond will open on this carbon. There is a formation of C negative. Carbon becomes positive. So this sigma bond will shift here and there is a formation of corresponding carbonyl compound. So you are getting here pH, here is the C, here is the H, and double bond O. That is the carbonyl compound starting material called as a benzaldehyde. It is the aldehyde or benzaldehyde. Plus we can get corresponding fragment, that is the H. Here is a H and here is a negative, means this is your fragment. And for this one you have to write corresponding synthetic equivalent. So what is the synthetic equivalent? The synthetic equivalent for this one, CS2 negative is your corresponding aldehyde. Just you have to put H, means it becomes again acetaldehyde. So the two fragments are there. One is the benzaldehyde and other is acetaldehyde. One is the benzaldehyde and other is the acetaldehyde. And then you have to write down the net reaction. So here the net reaction you can write for this one. Okay, so this is your TM, that is alpha beta unsaturated carbon compound. These are the fragments. One is acetaldehyde and other is a benzaldehyde. Let us see the next point, that is a net reaction. In net reaction, the reaction start from benzaldehyde. First step is formation of a carbanion. It is example of aldol condensation reaction. So first step is formation of carbanion. Formation of carbanion, in which the synthetic equivalent is a benzaldehyde. It reacts with a reagent. Reagent is a compound which makes change in the reactant. So reagent is alkali. It abstracts a proton. How it abstracts proton? This hydrogen is acidic in nature. This sigma bond open on this carbon. C becomes negative, H becomes positive. So this H positive is abstracted by the base, and there is a formation of a CS2 negative. CS2 negative. Okay. So C double bond O and H. It is also further stabilized by the resonance. How? Pi bond open on the oxygen, O negative, C positive. So this negative will shift here, formation of double bond. So you are getting corresponding, that is inorate double bond C O negative and H. So it is a carbanion and it is called as inorate. It is called as inorate. Inorate is more stable than the carbanion. First step is the formation of carbanion. Second step is attack of carbanion. Attack of carbanion. This reaction you have learned in the first topic, carbanions and their reaction. In the second step, what happens? The starting compound is the benzaldehyde, which is prepared on this connection. This benzaldehyde, it reacts with the carbanion, CS2 negative, C double bond O and H. So what happens? Pi bond open on the oxygen, O negative, C positive. This CS2 negative will attack on this C positive, and you are getting corresponding alkoxide, CO negative, R for alkyl, O for oxygen, alkoxide. You are getting corresponding alkoxide, CS2 C double bond O H. This is your number, suppose number 1, alkoxide. Alkoxide further undergo protonation, H positive, and you can get beta hydroxy aldehyde or ketone. So pH, here is the C, here is the OH, here is the H. We can write CS2 like this one, and C double bond O and H. This is your alpha beta unsaturated, that is a beta hydroxy compound, beta hydroxy aldehyde. It is a beta hydroxy aldehyde. So this is your beta hydroxy aldehyde. This beta hydroxy aldehyde, if you heat at 80 degree centigrade temperature, then it undergo dehydration, removal of water. How? Oxygen is more electronegative as compared to carbon. This sigma bond open on the OH, OH negative and C positive. Similarly, this sigma bond will shift here and there is a formation of double bond, and you can get corresponding TM, that is a alpha beta unsaturated aldehyde. EH, C, there is a H, double bond C, H, C, double bond O and H. It is called as alpha beta unsaturated aldehyde. It is called as a ceramaldehyd. So in general, we can write alpha beta unsaturated aldehyde. Okay. So in this way, you can write the disconnection of all alpha beta unsaturated aldehyde. Now there's one more example, number 3 example. Just now I will collect the only example. In this example, they can put R, any R. Okay. So here they have taken the R like this one, CS3. Then here is the CS3. Here is the CH double bond, CH, C double bond O, EH. Again, same thing, alpha beta unsaturated aldehyde. So you can carry out, it's a disconnection. I think there's no need to write down, it's a disconnection. You can write, it's a disconnection yourself. Number 4 example, here In the previous case, it was a 6-membered ring. Now here I have taken 5-membered ring, carbonyl compound C double bond O. Here is the alpha beta unsaturated aldehyde. So again, here is also alpha carbon and beta carbon. So first FGI, functional group interconnection, you have to add water and then it undergo disconnection. So the next example, number 4. Number 5 example. So you have to solve this 3, 4, 5, and if you are not getting, you can ask me. We will try to solve that one. Okay. Now next example under this category is, here we have taken again the 5-membered ring compound, the 5-membered ring compound as above. Here is the CS3, here is a CH3, here is a pi bond, here is a C double bond O and CH3. So again here is alpha carbon and here is a beta carbon, alpha beta unsaturated carbon compound. So again you have to add water and then it undergo disconnection. Next example you can take under this category is, here is again 5-membered ring compound. So they can increase or decrease the size of ring. Here is a double bond and here is a CHO, C double bond O EH. So here is the alpha and here is the beta, alpha beta unsaturated aldehyde. Just look, under this category we have taken near about the 6 examples. So you solve all these 6 examples. They are we have taken the 2 examples in detail, and these are the example. There is a 1, 2, 3, 4. This 4 example you have to solve yourself. So firstly you have to identify what is the type of that example, and you have to carry out corresponding disconnection. So here it is a 2-butanol. This compound is a 1, 2, 3, 4. Add 2. Suppose it is a carbon number 1, carbon number 2. So it is a butanol. Okay. So it is a 2-butanol. Even though like this also they may ask, they'll give the name of the compound and they'll ask, write down the disconnection of so and so compound. So it is a 2-butanol. So if they ask example by giving structure, you can write it's a disconnection. Even though if you they have given the name, you can also write it's a disconnection. So in this year you have completed all the examples from your textbook, that is the disconnection of alpha beta unsaturated aldehyde, right? Alpha beta unsaturated aldehyde. Any doubt in this one? In the alpha beta unsaturated aldehyde, any doubt? Firstly, you have to carry out FGI, functional group interconversion. It is an example of aldol condensation reaction. If you know aldol condensation reaction, you know when 2 molecules of aldehydes and ketone, one of them which have alpha hydrogen atom, if it undergo aldol condensation reaction, there is a formation of beta hydroxy aldehyde or ketone, which undergo dehydration on heating to give alpha beta unsaturated aldehyde. So this is the aldol condensation reaction, and under this you can write number of examples. Look, this example is also from your topic number 1 and also topic number 3. Means look, if you know topic number 1 very easily, you can understand the topic number 3, right? So same thing we are learning in the other way, different way. Retrosynthesis is a reverse of chemical reaction. Okay, so here we have taken one example. Now let us take the next example. Now next example we can take is your this one number under category 1. We have taken this example. Now under this category we will take the all the examples. Here is a such type of example. Now tell me what is the name of this compound, C double bond O and H. So it is your TM that you have to prepare. target molecule you have to prepare. So this is your aldehyde, right? This is your aldehyde. Leave it. This is R, and you can take this is your R. So if you see the list, now you'll see that that is the number 3. Under the category number 3, that is aldehyde or ketone. You are having this example, right? You are having this example. So it is the example of aldehyde or ketone. So for this one, also you have to carry out FGI, functional group interconversion. How can you prepare the aldehydes and ketone? By oxidation of alcohol. So you have to convert into alcohol. How can convert into alcohol? Just you have to add a hydrogen H and H on the CO. So you can get corresponding alcohol. This is your cyclic compound, cyclopropanone. Here is a C, here is a H, here is a O, and you have to add hydrogen H and H. It is a reduction reaction. Okay, so you have converted into corresponding alcohol. And you know the disconnection of alcohol. What is the type of alcohol, whether primary, secondary, or tertiary? Can anyone tell me what is the type of alcohol? Yes. What is the type of alcohol?
Primary.
Right. You are right. Very good. Right. It is a primary alcohol. The carbon where there is a OH, this carbon is directly attached to only one carbon. So it is a primary alcohol. You have to carry out the disconnection of primary alcohol. And you can carry out disconnection of primary alcohol by only one path. So it undergoes disconnection. It undergoes disconnection. Be the symbol of a disconnection. What you have to do disconnection? Disconnection means you are having the right to break any bond in this one. Even you can write, you can break this bond, this bond, this bond. Even there is a CH. You can also break that one. So CH, this OH, CO, CH. But you have to break in a such a way that you must get corresponding possible fragments. So you know the alcohol can be prepared from the carbonyl compound and corresponding, that is the Grignard reagent. So here this sigma bond will open on this carbon. C becomes negative, C becomes positive. So this sigma bond will shift here, and there is a formation of corresponding, that is a H. Here is a C double bond O, H, called as a formaldehyde. In organic reaction, if possible, you have to write the names of all compounds. Don't write only structure. You have to also write down its name below that one. Okay. So here you are having the C negative, and for C negative, you have to write down corresponding compound. How we can prepare this C negative cyclopentyl anion? We can prepare from corresponding Grignard reagent, right? Grignard reagent, and the Grignard reagent is like this one. So just suppose consider this your R. Okay, this is your R. So just you have to write down Mg and Br. Mg and Br. It is your Grignard reagent. It is also called as synthetic equivalent. Synthetic equivalent. Synthetic equivalent. So this your retrosynthesis means you have to prepare this aldehyde starting from, that is the formaldehyde and Grignard reagent. Now you have to write down the net reaction, right? You have to write down the net reaction. So cyclopentyl you consider it as a R, and then you can write corresponding reaction. In net reaction, what you do? The starting compound is a formaldehyde. Starting compound is your formaldehyde. Formaldehyde is H, C double bond O, and H plus it react with the Grignard reagent. This is your Grignard reagent. This is your R, and here is Mg and Br. So it is your Grignard reagent. It is your formaldehyde, right? It is your formaldehyde. When you are having a Grignard reagent, always the reaction starts in the presence of dry ether. In the presence of dry ether. So pi bond open on the oxygen, O negative, C positive. Here is a negative. So this sigma bond open on this carbon, C negative, and the C negative attack on this C positive, and O negative attack on this Mg positive. So we are getting H, here is a C, here is a O, here is a H, right? And you add here, that is the cyclic compound, and here is a cyclic compound, cyclopentyl, and here is a MgBr, Mg and Br. This is the magnesium complex. Magnesium complex is unstable, so you have to write in the bracket, it is your Mg complex, magnesium complex. This magnesium complex further undergo hydrolysis, addition of water in the presence of acid. How it undergo hydrolysis? There is a bond between the oxygen and magnesium, O negative, Mg positive. So H from water and OH from this water, you add on this OMg, O negative, H positive, Mg positive, OH negative, and you can get corresponding compound like this one. So here H, here is C, here is H, here is O, right? Here is H, and here is your cyclic compound. Okay. And actually you want the target molecule. So simply if you carry out, there is a oxidation, K2Cr2O7 H2SO4, or we can also use the PCC. PCC is a pyridium chlorochromate. It is a mixture of pyridine. It is a mixture of pyridine. It is a mixture of pyridine. Here is a pyridine, pi bond, and pi bond, plus CrO3 plus HCl. So it is one of the selective reagent which convert aldehyde, and it is alcohol, into corresponding aldehyde. So the H from this, and H from this, there is removal of hydrogen, and there is a formation of corresponding, that is the aldehyde. So you are getting H, C double bond O, and here is also such type of compound. So it is your TM, target molecule, right? Or you can say R. We can take R methyl, ethyl, benzene, or we can increase the size of the ring, and you can get the number of example. So if it is an aldehyde or ketone, that you have to prepare, then anyhow you have to convert into corresponding, that is the here alcohol, right? So if you convert into alcohol, depending upon the nature of alcohol, whether this alcohol is a primary alcohol or a secondary alcohol or a tertiary alcohol, we can also carry out its disconnection. If it is a primary alcohol, you are having one disconnection. If you are having secondary alcohol, you can carry out two disconnection, and if it is a tertiary alcohol, you can carry out its three disconnection, depending upon the nature of R. So here in your book they have given only one example from this category, that is the aldehyde. Okay, so you can write example yourself. Just you write instead of 5 member, you can write 6 member. You can also write PS. You can write also R, and you can add number of examples. Okay, so this is your also there is one example in your book they have asked. Just I will write that example. Example number 2. Previously we have written like this one, right? It was 5 member. Now here, if I write 6 member, then you are having the same disconnection. This is the next example. And suppose if I write here CS3, then it is the next example. So just here what you have to do, we have to replace the H of aldehyde by there is a CS3. So this H you have to replace by CS3. This H you have to replace by CS3. If you replace this H by CS3, you are getting again the next type of example. So here is the H. Here is also H. Right? Here is also H. Okay. And it is a CS3. Means it is a ketone. Okay. So here under this category, H is replaced by CS3. So you can carry out it's a disconnection by two ways. Why? Because you are getting the secondary alcohol. So this is the next example. Next example number 3, we can write, we can make corresponding benzene. We can make corresponding benzene. Here is the benzene, pi bond, pi bond, pi bond, and here is a C double bond O and a CH3. So again the same thing, just I put the pi bond in the benzene and you can write corresponding disconnection. So this is the next category, that is called as aldehyde or ketone. So you have taken also collected all the examples from here. Okay, so you have taken the two examples. One is alpha beta unsaturated aldehyde and second is aldehyde or a ketone. Aldehyde or a ketone. So again there are the I think you can take one more example under this category. The number 3 example. Now look here, you are having a such type of example. You can take any R. I have taken the R benzene, pi bond, pi bond, pi bond. Here is a C double bond O. Here is a O. Here is a CS2 and here is a benzene nucleus. What is the name of functional group in this case? Yes, can anyone tell me first? What is the name of the functional group? It is the Ester. Very good. It is the Ester. Now look here. Here in this case, number 5, right? Number 5 is Ester. Number 5 is Ester. We have taken 3, 4, and this 5. Ester. So first we find out what is the name of this functional group, and accordingly you can carry out it's a disconnection. In disconnection, so what you have to do, you have to just write down FGI, functional group interconversion. How can prepare Ester? Ester can be prepared from corresponding, that is the here acid and alcohol, right? You can prepare acid and alcohol. So here you have to add water on this one, H, OH and H. So we can get corresponding acid and alcohol. And you know alcohol how to carry out its disconnection. Here is a pi bond, here is a pi bond, here is a pi bond, here is a C double bond O, here is a O, H, it is your acid, right? And here is alcohol, H, O, here is a C, here is a H, here is a H, and here is your benzene nucleus, pi bond, pi bond, pi bond, and here is the alcohol. So when we carry out FGI, this TM ester will convert into corresponding alcohol, and this alcohol that you have to prepare. So it becomes TM. So you can say TM1 and we can say TM2. TM1 and TM2. Okay. So you can say TM1 and TM2. TM1 and TM2. So this TM1 cannot prepare directly. So you convert into TM2 and you can carry out corresponding disconnection. And you know the disconnection of TM2. So how to carry out a disconnection of TM2, that is the alcohol. Just now you have seen. What is the nature of alcohol? Primary, secondary? Yes, first. Nature of alcohol. It is the pH CS2OH. It is the primary alcohol. It is the primary alcohol. So in disconnection, what happens? It gives corresponding fragments like this one. This will shift here, C negative, C positive. This will shift here, formation of a double bond, and you are getting corresponding fragments. So fragments are, here is a H C double bond O, H plus, here is a negative pi bond, pi bond, pi bond, and here is a negative. And for this negative, we can write corresponding synthetic equivalent, and synthetic equivalent is your Grignard reagent, MgBr, Mg and Br. So it is called as a synthetic equivalent. Synthetic equivalent. And when you convert into synthetic equivalent, you have to write down corresponding net reaction. Net reaction. So what is net reaction? Net reaction, you start from the corresponding benzyl, there is a formaldehyde. So formaldehyde react with MgBr, pH MgBr. Here is Br, here is Mg, and here is pH. So it is your Grignard reagent. When you carry out reaction in the presence of Grignard reagent, you have to always use a dry ether as a solvent. So pi bond open on the oxygen, O negative, C positive. So this will open on this pH, pH negative will attack on this C positive, and you are getting corresponding magnesium complex. So here is MgBr, here is H, and here is pH. It is a magnesium complex. It is unstable. You have to write in the bracket. I told you that you have to write the name of all compound that you can write. Okay. Further, it undergo hydrolysis in the presence of acid. So here it undergo hydrolysis, oxygen negative, addition of H, addition of OH, and you can get here HC, here is H, here is a pH, and here is your O, and here is a H. Okay. So you are getting corresponding, that is the alcohol, primary alcohol. So you are getting corresponding alcohol. But you want ester. So further it react with acid, pH, C double bond O, and OH. Reaction takes place in the presence of acid. So OH from this, H from this, there is a removal of water. So you can write like this one. So suppose if I take H from this and OH from this, there is a removal of water, and you can get corresponding target molecule, pH, C double bond O, here is O, here is a CH2, and here is a, that is the pH. Okay, so this is your TM, that is TM1. Okay, this is TM1, and this is a TM2. Even though if you don't write TM1 and TM2, it also works. So in this way, you have prepared this ester, right? You have prepared this ester. So in this way, you have to prepare the ester molecules, and when there is ester, you have to carry out corresponding first FGI, functional group interconversion. So generally, this is only one example they used to ask, but if you change the R, you get the number of examples, right? End out in this case. So in this way, you have seen the retrosynthesis of some compound. We have taken near about 3 examples. So there are the 10 examples, but if you know alcohol, you'll find that the retrosynthesis of organic compound becomes very, very easy. Okay. So in this way, we have seen some of the examples. If you have any doubt, you may ask, even you can send me on the WhatsApp. We will discuss that example. So again, there are few examples. If possible, again, we will take those examples and then we can start a new topic. Okay, no doubt. Yes. Okay, then I think we should stop here. Thanks to all, and you can leave the meeting. Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you,
Thanks to
sir.
all. Thanks to all.